This is our 5th review assignment. We're going to look at describing graphs. So we're going to learn how to describe a graph. Now, the main thing about describing graphs is, well, we need to know what are the type of descriptive features. And so these are a list of very, very common descriptive features that we can, describe a graph with. Now, not all of these features apply to every single graph. Now, the main ones that you're going to see very, very common, and at least almost every single graph we can describe it based on these features, are going to be your x and y intercepts, your domain and range, and if it's a function or not. Those are those are some of the main ones that we could actually go through and describe a graph with. The probably the two important ones are these pieces here. Now, we are going to add to this list. These are concepts basically, or these are different descriptors that we technically should already know, or at least know of. And the other features that we're actually going to add are going to be how can we translate or move a graph, like shift a graph left or right, shift a graph up or down, things like that, dilations. We're going to examine that a little bit later in the class. So we're going to be able to add to this list of descriptive features. So let's look at a graph to make it an example here, right? So the shape, right? We look at this and we're thinking, oh, maybe it's U-shaped, but there's a common math name to it. It's called a parabola. Is there a line of symmetry? Yes. Meaning that this, if I draw a line here, right, now it's perfectly symmetric. And so I could say x equals 0. Opens upward or downward, opens up. Increasing or decreasing. Now, we have to say, as I move this way on my graph, is my graph going down or is my graph going up? So as I move this way along the x-axis, as you can see, my graph is going down, right? So as I move this way, my graph is going down. And then once I get about here, which is the vertex, if I move this way, my graph is going up. So we would say that this is decreasing, and then once we get to this value and we move here, that's going to be increasing. Now, I know that we haven't practiced that a whole lot, but just know that that's what it is, and we're going to develop that skill a little bit more. So I'm going to use the interval notation, and so I'll color it. And so we know that this red area, that's going to be decreasing, because as I move this way, my graph is going down. And then the green is increasing, because as I move this way, my graph is going up. So I'm going to say it's decreasing, negative infinity to 0, and then it's increasing from 0 to positive infinity, because it's going on forever that way, and it's going on forever that way. X and y intercepts. Crosses the x-axis here and here. So -1, 0, and 1, 0. And then my y-intercept is going to be 0, -1. My domain, well, if I flatten this all onto the graph, it goes on forever that way, it goes on forever that way. That's going to be negative infinity to positive infinity. My range, if I flatten that onto the graph here, it's going to start at -1, and it's going to go on to infinity. Are there any endpoints, meaning that does the graph stop at all? In this case, it doesn't, because it goes on forever that way and that way. So, no. Any maximum or minimums? So, is there a highest point or is there a lowest point on the graph? And so, in this case, there is a lowest point there at -1. Is it continuous or discrete? Well, there's no skips, there's no gaps or anything like that, so we're going to say continuous. And is it a function? Yes, because it passes the vertical line test. So those are all descriptive features. Another little thing that I kind of want to add is this whole increasing or decreasing. We generally only want to apply that rule when it's a function. If it's not a function, we can't really describe intervals of increase or decrease. So in this instance, this is not a function, and so it's not really going to apply. And so is it a function? No. The shape, it's a circle. Line of symmetry, well, there's technically an infinite number of these lines of symmetry, right? Because all I have to do is just draw lines that go through the center. So there's an infinite number of them, but, an example could be x equals 0 or y equals 2. X and y intercepts, there are an x-intercept here, which is 0, 0. And then I have a y-intercept here at 0, 0 and here at 0, 4. My domain, if I project this graph all the way down, it's going to be shaded from here all the way to here. So that's going to be from -2 to 2. My range, if I smush that all the way to here, that's going to be shaded in all the way to here. So if I project it onto the y-axis, that's going to be from 0 to 4. There are no endpoints. Now, an example of what I mean by endpoints would be like if my graph did this, right? Like just stopped there. I could say that that's an endpoint and that's an endpoint. So there's no endpoints. Max and minimum. Well, this is my lowest, so I have a minimum at 0, 0, and then I have a maximum at 0, 4. Is it continuous? And is it a function? No. So what did we learn today? Well, we went over how to describe a graph. Now, what are some of these descriptive features? Let's go back to that. Here's the list. And even though it's not blue, I want you to know that this might be a good reference for something for us to write down because it's going to be very important. This does conclude our lesson. If you have any other questions, please leave them in the comments.